So recently we had an upgrade on the elevator in our apartment, and that upgrade makes it so the elevator goes to the 13th floor every time it goes idle. I'm sure the designer of this upgrade intended to minimize the time we need to wait, but 13th floor is obviously a bad idea, not only because it is an unlucky number, but also because the majority of the people take the elevator from the first floor. And designating a floor in middle of the building is obviously not right. But what is the right floor? Is it floor 8? Is it floor 6? It can't be floor 1, right?
So here comes the question. On what floor should the elevator stop in order to minimize the average time passengers spend on waiting for the elevator? So there you go. Here is my elevator question. You can pause the video here and try to solve it for yourself, but I'm sure that our answers will be drastically different. Just because if you look closer into this question, you'll find that it is not a proper math question. Did I mention that the people from the 25th floor take the elevator more frequent than those in the 5th floor? Or did we consider the acceleration time of the elevator upon initiation? Or did I even mention how high is this building and how many floors it has? So with all these things, we'll have to restrict some of them in order to make this a proper math question. And to help with that, we need to first establish two variables. First is x, which is what we want, the floor elevator idles on. And then f, the max floor of the building. Of course, we need to set this variable, otherwise it will simply not work. And then we have x and f are both positive integers. When I'm solving this question, I have set four restrictions or four rules. Of course, you can set anything else, and you'll probably argue with me about this, and I don't actually care. I'll just do this question in the good old way I did it before. So the first is half of the people take the elevator from the first floor. By this I mean every time a person takes the elevator up, they will go the same way down. That's what I meant by the half of the people take the elevator from the first floor. This is kind of the truth in an apartment, but definitely not in any other business buildings. But we don't care about that since I'm mainly focused on the apartment building I'm living on. And the second rule is people from the second floor never take elevators. This is because they can walk by stairs. They don't need elevators. And three, ignore time used for initiating the elevator. I've mentioned this before, but I'll just ignore the time used by that because we don't actually know the exact time it used and also the ratio between that time and the time the elevator needs to move one floor up or down. And the fourth is people from floor 3 to F have the same frequency of taking the elevator. We must have this. If you don't have this rule, this question would just be meaningless. Anyway, let's get into the actual solving of this question. Okay, so here I divided that by two parts. One part is x is lesser or equal to 3, and another part is x is greater than 3. So the reason why I divide that on 3 is because when x is greater than 3, the elevator will go down to their floor if for people in floor 3 to floor X, and the elevator will go up to their to the passenger's floor if their floor is between floor X and floor F. But when X is lesser or equal to 3, the elevator will always go up for the people in floor 3 to floor F. So I have to divide it in two parts. And I know you are thinking that why not use absolute value to deal with this question. Well, of course we can use absolute value, but we cannot actually calculate that. So you same as this sigma symbol. I know you can recognize this sigma symbol. It's trying to get the sum of something, but how do we exactly calculate that? It's quite impossible actually. It's just for display, the same as the absolute value in here. So dividing it into two parts is a viable way to actually solve that. And there we go. So first of all, half of the people take the elevator from the first floor, and the time they need to wait is x minus 1 because the time they need to wait is directly related to the floor the elevator has to go through. And then from floor 3 to floor F, each floor will take a part of the rest half of the population. So for each floor, they will have this amount of population taking the elevator from that floor. And then I'm going to use the probably most hated symbol in high school, the sigma. So we are trying to get the sum of the time from I equals 3 to I equals f, and the time elevator takes to go to that floor is I minus x. And for x is greater than 3, the first part is still the same. Half of the people take the elevator from the first floor. But the second part, we need to divide them into two parts. From I equals 3 to x minus 1, the elevator will go down to that floor, so the time it uses is x minus I. From I equal to x to I equals to f, the elevator needs to go up to that floor, so the time elevator uses is I minus x. Let us first calculate this part, and this sum, if you have noticed, is the sum of an arithmetic progression. So we need the first element of this progression plus the second element of this progression, and divide all that by 2 and multiply all that by the number of elements in this progression, which is f minus 2. And we can see there is another f minus 2 before it, so they are gone. And then we shall turn the 1 half x minus 1 into the same form as the latter one, which is 4 under 3 plus f minus 2x. And add all these up, you'll see that x doesn't really matter because the x is gone, and we can get f plus 1 over 4. So this is our answer for x is lesser than or equal to 3. Whether x is 1 or 2 or 3 doesn't really affect the average amount of time passengers need to wait. And for the x is greater than 3, we can do the same thing. The first element plus the last element over 2, and all that times the number of elements. I've run out of space, so I'll just put f plus 1 over 4 right here, and then I'll erase the upper part. So first of all, I'm going to extract 4f minus 2, because this is kind of a common thing in this formula. And then inside of that, the first part is transformed into 2 times x minus 1 f minus 2. So the second part is obviously x minus 2 x minus 3 plus f minus x, and f minus x plus 1. And we can unfold the brackets and get 2xf minus 4x minus 2f plus 4 plus x squared minus 5x plus 6 plus f squared minus 2xf minus f plus x squared minus x. Combine all x squares and we will get the coefficient of x squared, which is 2. And then let us look into the coefficient of x. Positive 2xf, negative 2xf is gone. And we have negative 4x, negative 5x, and negative x, which makes the coefficient of x negative 10. The rest are all constants, and we'll say f is a constant in this case since we can't really build more floors or destroy some floors to reduce the time people need to wait. And as a common sense, constants won't affect the minimum value of a function. So I'll just ignore that. And if we want to get the minimum value of this whole thing, we only need to know the minimum value of 2x squared minus 10x, which is pretty obvious. It's negative 2 times 2, which is negative 4, under negative 10, which is 5 over 2. But 5 over 2 is lesser than 3, but while we have a restriction that x is greater than 3, so it is just impossible. But because this thing is a parabola, and this parabola is facing up, so if we want the minimum value, we'll just need to get as close to 5 over 2 as possible. And since x is an integer, this minimum point will be 4. So when x is equal to 4, this first part is 3 over 2, and the second part, that's 1, that's 2, and that'll be 2f minus 2 under 1. And the third part will be 4f minus 2 under f minus 3 and f minus 4. And when we add them all up, we can get, I'm going to erase this, not this, not this, not this. Alright. Okay, so 4f minus 2 under f squared minus f plus 2. And we'll compare this with 4 under f plus 1, which is the minimum value of the situation when x is lesser than or equal to 3. So if we make them to have the same divisor, we'll get f plus 1, f minus 2 as its dividend, and we'll get f squared minus f minus 2 instead. And when x is greater than 3, the minimum value is plus 2. So obviously the minimum value of the first situation is smaller, so the answer is clear. Pretty sure that many people will be angry about that, especially those living on the higher floor. They'll probably say this is rigged, but that's the answer. And if you are not satisfied with this answer, you can just calculate it for yourself with your own rules and leave a comment saying how you got the different result. And yeah, I guess that's it. Goodbye.